Hello everyone, welcome back to my channel. I am going to explain subject Software Project and Process Management Unit 4. We have Project Organization, Project Control and Process Instrumentation. These are the topics that we will be learning. First, line of business organization. Line of business organization means a part of company that focuses on one particular type of software product or service. So what does line of business organization says? That a part of company that focuses only on one software product or only one service. We have key roles. First one is SCPA, Software Engineering Process Authority. What does this authority does? Make sure that company's process is up to date and everyone follows it. It also enables exchange of information and process guidance to and from project practitioners. So what does this authority does is it checks whether the company's process, whether the process of project is up to date or not, and everyone are following all the rules or not. Next is PRA, Project Review Authority. The name itself says they will review how the project is going on. The responsibility of PRA is to check whether software project meets all policies, standards and practices. Checks whether project is doing the things right way or not. So what they will do, their responsibility is to check whether the project is following all the standards, all the policies or not. And also they will check whether the project is doing the right thing or not. Next, SEEA, Software Engineering Environment Authority. It is responsible for supporting and monitoring the standard environment, sets up tools, automation and shared resources for all projects, automate process, maintain reusable assets. So the name itself says that they will check the environment. So what they will do is they check the environment, and if they have all the tools for the automation or not, if the resources are available or not, they'll check all these things. Next is infrastructure. Line of business organizations provide human resource support, research and development, reusable components, tools and automation. So LOB also provides all these services as well. So in simple terms, line of business organization provides everything that needed for project to run successfully. So to run a project, what are the things that we need? It will be provided by this organization. Next is project organization. Means it is the arrangement of the people, team and responsibilities needed to successfully plan, build, test and deliver a software project. So project organization is nothing but we have to arrange the people and also the resources. What are the things that we will be needing for the project? So that is nothing but organizing. So there will be 4 teams here in organization. First team is software management team. So management is nothing but managing everything. Active participant in an organization and is in charge of producing as well as managing. It manages the whole software team from planning, requirements, design, resources, risk, stakeholder satisfaction, quality assurance. So what they will do, they will manage everything from planning to the requirements to designing, and also they'll check whether the resources are proper or not, and also they'll check whether the stakeholders are satisfied or not. They'll also check the quality of the project is up to date or not. Next, software architecture team. What this team will do is they'll provide the design, or they will provide the structure of the project. A team that designs the structure of software system, makes key technical decisions, chooses components and ensures everything works together as one system. Create the architecture, stabilize using elaboration phase, integrate components, evaluate risk and technology. So what they will do, they will make the structure of the project, or they will design the project. Next, the software development team is a group that writes code, builds the components, fixes issues and turns design or architecture into a working software product. It is responsible for coding, unit testing, fixing bugs, maintaining the code. So software development team, development itself says that we are developing the product. So what we will do here, we'll write the code, we'll also do the testing. If there are any bugs, that will be fixed here, as well as the code will be maintained. Next is software assessment team. Assessment is nothing but testing or checking. involved in testing and product evaluation activities in parallel to ongoing development. So what we will do here will be testing whatever the project is done, like the project, the coding and all these things will be done parallelly, and the testing will also be done parallelly. Verify whether software works correctly, meet requirements and is being built properly. So what they will do, that whether the software is working properly or not, all the requirements are built or not, all those things. And what are the responsibilities of this is to test the software, review project artifacts, identifying defects, independent evaluation. All these are the responsibilities of software assessment team. Next is this table. So here we have 4 phases: inception, elaboration, construction, transition. Software management will be working high, or the software management will be high in inception phase. Software architecture will be high in elaboration phase. Software development will be high in construction phase. Software assessment will be high in transition phase. So remember this table as well. Next is process automation. So automation is nothing but automating the process using tools and softwares to reduce manual work in the project. So why do we automate? Is to reduce the manual work. So there are 3 levels in automations. First is meta process level, macro process level, micro process level. So let us understand meta process level. Meta process automation means using tools and methods to automate these high level management activities. So there will be so many activities going on in a project, and to automate the high level activities we use meta process level. They come under meta process level. It is like framework that tells how project should be started, how risk should be handled, how quality should be maintained. So all these things will be said in the framework here. Next is macro process level. It focuses on main phases or stages of single software project. So this will focus on single phase or single stage. It includes requirement phase. So what they will include here is automating the requirement phase, automating the design phase, automating the implement phase, automating the testing phase, automating the deployment phase, and automating the maintenance phase. All these phases can be automated in macro process level. Next is micro process. Macro means the largest one, and the micro means the smallest one. It is the smallest activity done by individual developers or testers. So it is the smallest activity, and writing code, unit testing, code review, debugging will all be automated here. Next is project control and process instrumentation. Let us understand what is meant by project control. Project control means making sure the project is going as planned. It involves monitoring, controlling, comparing and correcting project activities. So project control is nothing but, in simple terms, controlling the activities that are done in the project, right? It involves monitoring. So we do check what are the things that are going on. We monitor every step. That is nothing but project control. Next, process instrumentation. What it means: the system of tools used to monitor, measure and control project process. So these are the instruments that we are using to control or to measure or to monitor the project. These are tools in observing project activities and taking decisions. Okay. Next is central management issues of complex surface. Modern software systems are large, complex, distributed and continuously evolving. So in big projects, what happens? There will be so many lines of code, and it will be difficult to handle it, to manage it, and it becomes complex as well. So there will be issues as well. There will be so many issues, and we are discussing the central issues, like the most occurred issues. In that, first one is difficulty in developing correct design. Difficulty in developing correct design. Designing system correctly at beginning is hard. Why is it hard? Users may not know exactly what they want. Requirements can change. Technologies change fast. If design of banking app is wrong, later it becomes expensive to fix. So when we are first designing a project, it is really difficult to hard, because we don't know what to design, and also sometimes the users do not know what they want. And also, meantime, the requirements will be changed, the technologies also will be changed, right? So it will be difficult. And also, for example, if we design a banking app and if there are some mistakes, it will be really hard later on to fix it. Next is difficulty in managing and handling risk. Every large software project has risks, and managing these risk early is difficult. Why is it difficult? Impossible to predict all future problems. Why is it a central issue? Because if risks are not identified early, project may fail. So managing and handling risks are also difficult, because when we are at the start of the project, right, we don't know what risk will be occurred later on in the future. And if we don't know what are the risks that will be occurred, we don't know how to handle it, right? And also it will be difficult to manage it. And also if these risks are not identified earlier, after the project is made, it will be difficult to manage them. And also there are chances that project can be failed. Next is difficulty in reducing complexity. Large software equals to many modules plus many interactions. Managing all of them becomes complex. Why? Millions of lines of code, multiple developers working together. So when there is a large project, what happens? To reduce the complexity, it will be difficult. So it will be complex, right? If the project is large, there will be so many modules and so many teams working on. There will be millions of lines of code. So it will be difficult to reduce that complexity. Nothing but it will be difficult to make the simpler version of it, or to understand it in simple way. Next is difficulty in making software progress and quality tangible. You cannot see software like a building or a physical product. It's hard to show real progress, quality, internal improvements. Software is intangible. So when we are making a software, right, we'll be writing lines of code, and by seeing the code we cannot understand whether we are progressing or not. Until or unless we run, we test, we do so many things, we will not understand whether the project is building or not. So it is intangible. Software is intangible, nothing but it is invisible, and it will be hard to check the progress and also the quality. So until or unless you test it, you use it, you will not understand the quality, right? Next, difficulty in automating the overhead and bookkeeping activities. Software project need many supporting tasks. So for a software we need so many tasks, that will be documentation, version control reviews, testing, reporting. Automating them is difficult because different teams are using different tools, so there will be so many different tasks, right? And to automate them, it will be difficult because there will be different tools used in that. And we have modern tools as well that we use in automating. They are Jenkins and DevOps pipelines. Next topic is the 7 core metrics. 7 core metrics in the sense we have 7 metrics here. Software metrics. Metrics, nothing but the measurement, are used for implementation of activities and products of software development process. So these are the measurements that help us evaluate how software development process is going, how good software product is. So what software metrics says is, we are measuring the software, we are measuring the implementation and development process, everything. Why do we need this? Is to calculate cost and schedule accurately, to estimate project progress, to evaluate software quality. So why do we want to measure the software process or software development? So that we can calculate the cost of the software, we can estimate when the project will be completely ready, right? We can also evaluate the quality when we measure it. Indicators. Let us understand what is indicator. Indicator means it provides meaningful information about project, process and product. There are 2 types: management indicators, quality indicators. We learned about 7 core metrics, right? So 3 will be in management indicators and 4 will be in quality indicators. Let us see one by one everything. First is management indicators. It helps project managers understand whether project is going as per plan or not. Management, in the word it says managing, right? So what they will do is whether the project is going as per the plan or not will be indicated. In this we have 3 core metrics, right? First one is work and progress indicator. Shows how much work has been done. So in work and progress indicator, it will show how much work we have done, how much work is pending. What it will check: percentage of tasks completed, milestone achieved, modules finished versus planned. So it will also tell us how much work we have completed, how many milestones we have achieved, how many milestones are there to be achieved, how many modules are finished, and how many we planned at the beginning. Next, what is the need for this? It helps us to monitor actual progress. It helps us to detect delays early, adjust schedule if needed. So when we use this work in progress indicator, it will help us to see how much we are progressing, how much amount of work we did, and if there are any defects, detects delays early. Like for example, if you are doing a particular process late, so we can understand that this project will be completed in so and so time, right? Adjust schedule if needed. We can also adjust the schedule. Next is budgeted cost and expenditure. Measurement of cost, expenditure, money spent versus money planned. So what we do here is we measure how much cost is used in making of the project, how much money we spent and how much we planned. What we check here is if the project is within our budget or not, how much has been spent so far, what will be the expenditure, what is the actual cost, and how much we earned. We'll be checking all this here. We'll be measuring all this here. Next is staffing and team dynamics. What happens here is staffing is nothing but the people, the staff, right? It tracks team size, skills, productivity. So what we measure here is we measure the number of people in the team, we measure their skills, we measure their productivity levels, and also we check required staff is available or not. Like depending on the project, we do have that particular staff or not. We'll check the experience of those people, we'll check whether they are properly communicating with each other or not, if there is proper coordination between them or not. We'll also check the performance of the team, like how they perform in this particular project or in this particular situation. All this will be measured here. And why do we need this? Because understaffing, delay, overstaffing, unnecessary cost. So for a particular project, if we need 5 people and if there are only 4 people, then this project will be completed little late than the actual time, right? And if there are if we need 5 people for a project and if there are 7 people, that means that 2 of them are paid unnecessarily, right? So that is what unnecessary cost. Next is quality indicators. So we have completed three metrics, right? 4 are left. Quality indicators tell us how good software is. So quality indicators nothing but they tell the quality of the software. They show reliability, maintainability, stability, performance levels. They'll show all these things. First one is traffic change and stability. So it measures how frequently changes are made. High traffic, many changes, less stable. So what we measure here is how frequently we are making changes. And if the traffic is high, that means we need to make many changes. And if the traffic is high, that means the stability of the project is very less. If the traffic is low, that means we have to make low changes and the project is more stable. Stable software needs few fixes and modifications. So if the project is stable, then we do not need many modifications, many changes are not needed there. If small change affects many modules, that means software is not stable. So if we are making any small change and if it is affecting the whole module, that means our project is not stable. Breakage and modularity tells how easily software breaks when changes are made. If modifying one part causes failures in other parts, breakage is high. So when we are making changes in one module and if that change in one module is breaking the other module, that means our project is not stable. Alright, if we are making changes in one module and because of that one change the breakage is happening in other module, that means our project is not stable. Alright, next is software are divided into modules. Good modularity means change in one module does not affect others. So if the change in one module doesn't affect anything in other module, that means we have good modularity in our project. Next is rework and adaptability. Measures how much extra work is needed after changes and how easily the software can adapt to new requirements. So after making changes, how after making changes, how much work is left to do so that our project can work like before. That is nothing but the rework. And if there is lot of rework, that means our project was not stable. Adaptability says how easily the software can incorporate new features. So what does it mean by adaptability? If we are making any changes in our software and it runs properly, smoothly, that means our project is adaptable. When we are adding new features and it runs properly, that means our project is adaptable. Good adaptability means easy to modify, and if the changes that we are making does not make problems in other modules, that means we can modify it more and we can make the software better. Next, mean time between failures, MTBF, and maturity. Measures reliability and stability of the software. So it measures the reliability and the stability of the software. Mean time between failures means the average time between the software runs before it fails. So from the start of the project and till it fails, this time is called mean time between the failure and maturity. Mean time between the failure. Next, maturity means the stability of the software. Next, life cycle expectations. Describe what we expect from software process throughout the entire software development. So life cycle expectations. Expectations is expecting something from life cycle. Life cycle in the sense here we are talking about software development life cycle. So what are the expectations that we have from this process is predictability, quality, visibility, control, consistency, improvement. So these are the things that we will be expecting, like the control of the project, consistency, improvement, and the quality and all these things. Next, pragmatic software metrics. What is this? It says it is a metric that is practical, useful, easy, and directly helps in decision making. So this measurement is actually a practical way, and it is also easy, and it also helps us in making better decisions. So what are the characteristics here? Are simple and understandable. It is simple and we can understand it easily. Next, objective and reliable. We can rely on it. Next, consistent. It is consistent, timely, cost effective. Next is metrics automation, means using tools and software to automatically collect, calculate, store, and report software metrics. So metrics means measurement, automation means automating something. What we are doing here is we are automating the measurement. Whatever we have learned, right, about the measurings, metrics, and all those, we are automating all those things. So for that we are using certain tools and softwares. And why do we need this? It saves time. So if a particular tool measures the work for me, then it will be easy for me, right? It will save time, it will improve the accuracy, will get the proper accuracy, and also will get the real-time updates, better decision making. When we get the proper the accurate results, the decisions will be better as well. So this is all about unit 4. Hope you liked it and also understand it, and thank you for watching. Bye bye, see you in the next video.